Welcome to my channel, Math with Amina. We are going to solve question number 5 of the exercise 10. Question number 5 has 3 parts. The very first part asks, if a number is divisible by 12, what other numbers must it be divisible by? So, if a number is divisible by 12, let's say it is 24. So 24 is divisible by 12, so 24 will also be divisible by the factors of 12. So therefore, in general, we say that if a number is divisible by a certain number, then it must also be divisible by all the factors of that number. So in here, the factors of 12 are provided as factor pairs: 1 multiplied by 12, 2 multiplied by 6, 3 multiplied by 4. These are all the factor pairs of 12. So if a number is divisible by 12, it will also be divisible by 2, by 6, by 3, and by 4. Another part of the question, if a number is divisible by 36, what other numbers must it be divisible by? So we find the factor pairs of 36. If any number is divisible by 36, it will also be divisible by the factors of 36, which are 2, 18, 3, 12, 4, 9, and 6. So if a number is divisible by 36, it will also be divisible by 2, 4, 3, 6, 9, 12, and 18. The third part of the question is a little bit different than the first two parts. It asks, how could you test if a number is divisible by 12, 15, or 24? So in short, we can say by expressing the number as a product of prime factors and then check if the prime factors of 12, 15, and 24 are included in the product or not. What do we mean by that? In order to understand it, I have here made a simple example for you. Let's say the number we want to check if it's divisible by 12, 15, and 24, it is 360. So what do? As we mentioned in here, we express a number as product of prime factors. So in here, as you can see, we have used the tree diagram in order to find the prime factors of all those numbers that are involved in our question. And then we compare the factors now. 12 and 360. The factors of 12 are 2 multiplied by 2 multiplied by 3. The factors of 360 are 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 and multiplied by 5. So now, when using prime factorization to check divisibility, the number must have all the primes of the divisor. In here, the divisor is 12. So it must have all the primes of the divisor with equal or higher powers. So now in here, this number 360, it has the power of the primes greater than the divisor, which is great. Therefore, based on this, we can say that 360 is divisible by 12. 360 is divisible by 12 because it has all the factors 12 has, and the powers are more than the prime factors of 12. Therefore, 360 is divisible by 12. Then we check 15 and 360. The factors of prime factors of 15 are 3 and 5. The prime factors of 360 are given in here as before. The powers, if we compare the power in here, the power are higher of 360 compared to 15. So this says that 360 is divisible by 15. Again, let me say it again, that when we are using prime factorization to check divisibility, the number must have all the primes of the divisor. That number is 360 and the divisor is, in this case, 15, with equal or higher powers. Either, let's say, if in here the power of the powers of the primes were less than this, then it would have had been not divisible. But in here, as we said, it has to be equal, either equal or higher. If it's lower, then it's not possible. 24 and 360 are compared. Their prime factors, as mentioned in here. When we express their prime factors, the powers we can check. In here, as you can see, the powers are equal or greater. So since the power of the primes of this number is greater than the power of the prime of the divisor, therefore 360 is divisible by 24. One thing you have to keep in mind is that 360, in this example in particular, 360 is divisible by 12, 15, and 24. Any number we want to check is divisibility by certain given numbers. We have to express it as a product of prime factors. Then we have to compare the factors and check their powers. If it's equal or greater, that is the criteria for divisibility. If it's less than that, then it's not possible. So in here, on the other hand, if we check if 12, 15, and 24 are divisible by 360, you will see that if we compare, now 360 becomes the divisor. So 360, the powers are higher than 24, the power of the primes. So therefore, since the power of primes of 360 being the divisor are higher than the number itself, therefore these 12, 15, and 24 are not divisible by 360. So I hope the concept is clear. That's all for this question. Happy learning.